All right, for Tuesday, the 27th, we are going to go through the first page for sure of this practice test together. So for number 1, it says, how do you know by looking at a quadratic equation? I want you to, whoops, sorry, my pen's not activated very well. There, sorry about that. So quadratic equation, I'm going to go off to this side. That's where y equals ax squared, and you should as well, plus bx plus c. Whether the and to get full points for this, you have to write down everything I do. Whether the parabola will be wider or narrower than the parent function. And the parent function is y equals just 1 x squared. And so you need to know that that's all about the a. Okay, so it's all about this lead number that's sitting out front. Let me go highlight it for you guys. So it's all about this guy being compared to 1. And remember, if it's greater than 1 in absolute value, and remember absolute value is just the positive, so that means like if there was a 3, that's bigger than 1. If there's a negative 3, its absolute value is 3. Which is also bigger than 1. So you're looking for a number without the sign where it's bigger than 1. That will stretch it and make it narrower. What does that mean? Y equals x squared is the parent function. Y equals negative 4x squared. This 4 is bigger than 1. So I know they say the absolute value, but just look at the number without the sign. All right? And it's bigger than 1, so it's going to stretch it to 4 times its height, like gum being stretched. And if that absolute value of a is less than 1, so basically you're sort of looking for fractions like half and a third, and negative a half and a negative a third, it will be wider. How do you know whether it'll open down? That's also about the a. If the a is positive, it'll open up. This one opens up. This one, with the negative 4, opens down. So you can write if a is negative, it opens down. All right? So those first 2 questions are all about the a. For part C, how do you know if its vertex is at 0, comma? And that's when you see y equals just ax squared and then just a number. Like here, 4x squared and a minus 2, negative 2x squared and a 3. And so on all of these, what we've got basically is that b term equals 0. You won't see it. So you should write down when the b equals 0. And remember, the b is what's in front of the x term. So anytime you don't see an x in it, its vertex is going to be at 0, comma something. All right, so let's go match these up. This is going to be narrow because it's a 4. It's going to stretch it. It's going to open up, and its vertex will be at 0, comma negative 2. So that one's going to go with C. Number 3 is going to open down because of the negative from 0, comma 3. Because when these all have a vertex at 0 because I'm not seeing that x term. All right, so that's going to be D. This one is going to be down because of the negative. And there's nothing here, which means it was plus 0. So it's going to be down from 0, 0, which is A. And the last one's going to get wider because of the 1/2. It's going to squish it to half its height and make it fatter. It's going to open up because that's positive. And it'll open up from 0, comma, and then there's no number here. So from 0, 0. So that one's B, even though it was the only one left. So now let's see if we can look at this guy. Okay, you might even want to write the A is a negative 5. The B is missing, so we know its vertex is at 0, comma C, or 0, comma 2. All right, and let's go answer these questions. Does it open up or down? That's about the A. The A is negative, So it'll open down. You want to write a less than 0, that means a is negative, but it didn't say to explain why. Is it wider or narrower or the same as x squared? We look at that a again, and we ignore the sign, and we think of it as being a 5, and it'll stretch it to 5 times its height. The negative makes it open down. The 5 stretches it and makes it very, very narrow. What effect does the +2 have on the graph? What the C does is moves it up or down from the origin. So you'll notice that for number 2, we matched it with this one, and that vertex is at 0, -2. It moved it 2 down. So if this is a +2, it's going to move it 2 up, or the parent function 2 up. Now I'm going to do one more of those, and so are you, off on the side. Suppose y equaled 1/2 x squared minus 3. And to get your points for today, I want to see that off on the side. Does it open up or down? You write that in there. Is it wider or narrower than the parent function? And what effect does the -3 have on the graph? And I'm going to repeat those. In blank number 1, you're going to write whether it opens up or down. In blank number 2, you're going to put whether it's wider or narrower or the same as the parent function. And in blank number 3, you're going to tell me what effect the -3 has on the graph. When you're done with that, you're going to raise your hand, and I'm going to check these 3 answer blanks in class. Distance learners, pause the video and do it now. So the answers to those would be up, because that's a positive 1/2. Wider, because it makes it a half its height and squishes it down. It makes it kind of pop out the sides. Imagine me taking somebody and squishing them to half their height. They're kind of all pop out the sides. It's going to get wider. What effect does the -3 have on it? 3 down. Now you need to know how to graph. All right, so to graph our parabola, the first thing we need is the vertex. Now, if you wanted to, you could say x equals, and remember there's a formula for the vertex, -b over 2 times the a. That you need to memorize. But when the b is missing, I want you to write x squared plus 0x minus 3. Or when b is 0 and it's missing, when we do -b, we'd have a 0 on the top. So that's why the vertex is always at 0 when you just see these, the b term missing. So we put that in the middle of our graph, our table, and it'll be at 0, comma. When I square 0 and subtract 3, I'll be at -3. So notice that vertex moved 3 down, which we talked about in the other 2 examples. Now we need some other points. I like to use 1 and 2. I like positive numbers. What do I do with the 1 and the 2? I want you to take your pencil and draw an arrow up here and do 1 squared, which is 1, minus 3, which is negative 2. We'll go plot it. And then I'm going to take 2, travel it up here, square it for 4, subtract 3, and get a 1. So I'm putting them in to x squared minus 3. So I'm going to be at 2, 1. Because of the symmetry of the graph, when I put in a -1, I'll get the same as what I had when I put in a 1. When I put in a -2, I'll get the same thing as with a +2. So there's symmetry about that vertex. Where was the vertex? Because there was no b term, it's at 0, comma, the c term. Had that been y equals x squared plus 5, it's at 0, comma, 5. Make sure you write everything down that I'm writing down to get all your points for today. There's a lot of points today. There's 5 of them. Okay? Now, if that had been y equaled x squared plus 2x plus 5, then the vertex isn't at 0. And that'll be our next and last example for today. Now, we haven't drawn our parabola. It has to have arrows. It comes down, and it swoops like this. What is its domain? All reals. And I think you're allowed to use the symbol for that. Anything. X can be anything. And I can square it and subtract 3. But the range is about what y can be. So put a y down. Go to your y-axis, right here. And you'll notice that I never get below the vertex. So I want you to draw a little dotted line right here. Think of it as like a fence. That entire red parabola is living above the vertex, which was located at -3 or 3 down on the y-axis. Now, had it opened down, you don't need to, this is one thing you don't need to write. So I'm going to go change my color here and the thickness. Let's just do, perfect. Had it opened down, then we still have that fence, but now y is less than or equal to -3. So the range needs the y, needs the right symbol, and you have to put the number on the y-axis that it's always below. Last one for today. Actually, no, I want to get, I think, through number 11 today, and we'll work on the rest of it tomorrow. So now our A is 3. Go ahead and write that down over here. Everything I write down you do, unless I write it in blue. B is 12, not 0. So my vertex is not at 0 comma something. If it was like this, it'd be at 0 comma 4. But with that B term there, all right, I have to use the formula. So I want you to write it down. The vertex is at x equals the opposite of b, you have to have that memorized, over 2 times the a. So you go back over here. It's the opposite of my b, which is 12. So we'll do -12 over 2 times the a. 2 times 3 is 6. -12 divided by 6 is -2. You're not done. My vertex is at -2 comma, so I know I need to go 2 to the left, but I don't know where I'm supposed to go here. Do I go 5 up, 6 down? Who knows? How do I figure that out? I go to my calculator. So at this point, as you see everybody taking out a calculator or asking me for a calculator, again, you won't get all the points if I never see you using a calculator, all right? So, and there's 5 points today, and one of them was for raising your hand, having me check that. One is that you write everything down. One is that when you get to this part, I'll know at about 13 minutes into class, you're going to be taking out a calculator, okay? And what are you going to do? You're going to go up here, and you're going to put the -2 in for the x. All right, so on your calculator, and again, write it under here, you're going to write the y equals 3. You're going to do a -2 squared on your calculator plus 12 parentheses, -2, use those parentheses, plus 4. And you're going to raise your hand when you have that y coordinate, and I will check it. Okay? The next step, the axis of symmetry. So first of all, okay, raise your hand once you have this written out and you have the y coordinate. I'll come check it. Distance learners, pause and then replay. So I'm just going to do this in my head because I don't have a calculator out right now. So that's going to be minus 24, which is -8. Sorry, -12, and then plus 4, which will be -8. I did the whole thing in my head. So the vertex is at 2 comma -8. I'm going to go put it on my graph. 2 to the left, 8 down is my vertex. The axis of symmetry goes through your vertex. I'm going to do it in a light color, and I want you to use just a light pencil. This is the axis of symmetry. It's like the spinal column or the splitter of your parabola. And it's everywhere where the x's equal -2. The equation for the axis of symmetry, equation means it needs an equals, and it's where the x's are, the x-coordinate of your vertex. Whatever you get. If your vertex was at 3, 9, x equals 3, you should write that down, is your axis of symmetry. The y-intercept is what we get when we put 0 in for x. So go ahead and put a 0 down. When you put the 0 in for x, this becomes 0, 12 times 0 becomes 0, and all I get is 4. So 0, 4 is my y-intercept. And now I'm going to use that splitter, see if you can see it, use the splitter, or the axis of symmetry, to walk to my other point. So I'm going to walk towards the spinal column, or the splitter, or the axis of symmetry, 1, 2 steps, and I'm going to walk away, 1, 2 steps. That's going to give me my other point. You walk to the axis and then the same amount of steps away. Let's go ahead and draw our parabola, just like that. And my other point is at -1, 2, 3, 4, 4. Domain, all reals all the time. Range is y. And we have to see, are we above or below a fence? We are above it. Where is our fence? Down at -8. And I think that'll be it today, because you might have had to pause this, and it's at 17 minutes, and I thought it'd take about 20. So once you're completely done, you're going to raise your hand again. All right, and I'm just going to make sure everything's ready to roll, and you will get an easy 5 out of 5 for me today. Distance learners, you're going to take a picture of this, and you're going to send it to me via either Remind or by email. I have to sneeze. Peace out, Girl Scout.